Section 2.1 talks about rational numbers, the multiplication and division of those numbers. First of all, a rational number is any number of the form a divided by b, where a and b are both integers. We think of rational numbers as fractions. Some examples are shown here, like 1/2, -3/4. But then even the numbers 6, 0, and -4 also are considered rational numbers. Can you think about why? Well, 6 is actually a fraction. It's the number 6 over 1. -4 can be written the same way, -4 over 1. So those are easy to think about. But what about 0? 0 can also be written as a fraction, like 0 over 5. As long as 0 is in the numerator, then that's the correct fraction, which is equivalent to 0. All of these numbers are rational numbers. Some important properties that we need to be aware of for rational numbers mostly deal with negatives. Here in the very top of the screen, you see 3 different fractions that are all equivalent to each other. It doesn't matter where the negative is, the top, the bottom, or out in front. They all are equivalent. One more property you want to keep in mind is if there is a negative symbol in the numerator and the denominator, those two can cancel because we know that a negative divided by a negative is a positive. Here you see an example of some equivalent fractions. The negatives on the top for the first one, on the bottom for the second one, and out front for the third one. None of these are considered more correct than the other, but I will say that this one in the middle is not quite as common. Usually you'll see the negative in the numerator or out front. When multiplying rational numbers, we multiply straight across the top and straight across the bottom. So you're multiplying the numerators together and multiplying the denominators. One property says we can actually multiply by any number at all in the numerator as long as we do the same number to the denominator. We're going to make use of that in just a few minutes with making equivalent fractions. And finally, dividing fractions is just like multiplication. The only difference is you have to flip the fraction in the second part. We refer to this as its reciprocal. So if I want to divide a over b divided by c over d, I would take a over b times d over c. The first fraction stays the same, the second fraction gets flipped around, and then it's just a multiplication problem. Let's look at some examples. In the first one, I'm going to multiply straight across the top and straight across the bottom. But when we get to 9 times 14, this is a really large number. I want to grab a calculator, but remember we're trying to do things without a calculator. So let me go off to the side here. And after all this arithmetic, I find the denominator is 126. So that was kind of a pain, but also, not only, the answer that I just got here is not in reduced form. So let's look at some and just practice some reducing of fractions, and then we'll come back to this problem in a little bit just to see an easier way. What I mean by reduce is we want to look for common factors. 12 over 18 has some common factors. In fact, it has a common factor of 6. I can rewrite the numerator as 6 times 2, and the denominator is 6 times 3. Now, it's important to note that there are a lot of common factors here, and I could have written a lot of different ways, but we want to pick the biggest number that's in common to both. That'll save you a lot of time. These 6's, because of our property, can now cancel, and it reduces to 2/3. In the next one, when I try to think about common factors between 14 and 35, I remember that 7 is in common. 7 times 2 and 7 times 5. I can reduce by canceling the 7's to 2/5. As long as the common factor is in the top and the bottom, we can reduce. So let's look at this fraction that we just did. Here, I see a common factor, but it's with the 7 and the 14. Even though they belong to two separate fractions, one's on the top and one's on the bottom. What I can do is rewrite that 14 as 7 times 2. Now I get the 7s to cancel. What's left in the place, though? When we canceled that 7 in the numerator, it really reduced to a 1. So I want to write that there just to remember. Now multiplying across the top, I get 1 times 5 over 9 times 2. These are equivalent fractions, exactly the same value, but this one at the bottom is reduced. It also allowed me to skip all that additional multiplication I did to the side. Let's practice reducing some more. Here there's now a negative in the problem, so I just want to make sure that whenever I write it, one of the values has a negative. I know that 24 and 32 have an 8 in common, so I'll write this as 8 times negative 3 and 8 times 4. Those 8's cancel, and I'm left with negative 3/4. The next one, the values are getting a lot higher. I know that both of these are even, so 2 divides into each of them. Also, I know that 9 divides into each of them. So let me try that first. 9 times negative 8 over 9 times 10. This is reduced, but it's not reduced completely because I didn't choose the highest number. In fact, I just couldn't think of it off the top of my head. But now that I have it reduced, I can keep working. I know that these two numbers are also even. So I can write it as 2 times negative 4 all over 2 times 5. And the answer is negative 4/5. Even though it took me a little extra work, nothing's wrong with doing it in multiple steps. Now, variables work the same way. The numbers 9 and 17 have nothing in common, but I have an x in the numerator and an x in the denominator. They can also reduce, and I'm left with 9/17. In the next one, x and y don't have anything in common, but the numbers do. 8 and 36 both have an 8 in them. The 8's cancel, and I'm left with an x in the numerator and a 4 times y in the denominator. Here's some more. In this top problem, the numbers have something in common and we have y's in common. So I'm going to do both. I'm going to write out the common factor, which is 3. And then reduce. What's left over is a negative 3x in the numerator and a 10 in the denominator. Down below, I see 2 negatives that can cancel, a's that can cancel, and c's that can cancel. No numbers are in common between 7 and 9, so I'm left with 7b on the top and a 9 on the bottom. Let's go back to that multiplication and practice that skill of canceling. This time, instead of me writing out the factors, I'm going to try to do more work actually on the problem. Think of it this way. I want to look for common factors and cancel out what's in common. I know that 8 and 24 have an 8 in common, so what I can do is divide each of them by 8. Not only that, the 18 and 9 have something in common. They're both divisible by 9. Now I'll multiply across the top and across the bottom. Had I not have done that, the numbers would have been extremely large. This saves a lot of time, is much more efficient for multiplying fractions. Let's try 2 more. In this one, 14 and 8, they're both even, so I can divide both by 2. 6 and 32 are also both even. I'll divide both of those by 2. I don't see anything else in common, so I'll have to do the multiplication. I have a negative times a positive, so my answer is going to be negative. 3 times 7, all over 14 times 6. Last one on here. The negatives cancel. 4 and 14 are both even, so I'll divide by 2. And I think that might be it. I don't see anything else in the denominator that has anything in common with the numerator. So I'll multiply across the top. And across the bottom. But wait, something was in common. These two numbers have a 3 in common. I must have missed something. I can either go back and look for what I missed, or I can redo the problem. Let me just go back and see what I might have missed. Looks like I missed this 9 and 15. 3 goes into both. That's what I was missing. Now multiplying across the top. This time I get 21 over 10. That's in simplest form. I know that because no numbers go into both of them. Okay, a few more, this time with letters. 7 goes into 14 twice, and 9 goes into 45 5 times. I also have a common factor of y. Multiplying straight across the top, 1x times 2 is 2x. And straight across the bottom, 1 times 5 is 5. In the next one, I have a common factor that goes into 7 and 14. But I think that's it. The letters, C on top, C on the bottom, B on top, B on the bottom. And now I'll multiply across. Negative 6 times 2 is negative 12. And in the denominator, I have 1 times a times 5, or 5a. Last thing, let's look at some division. Remember from the beginning, we talked about how division is actually a multiplication of the reciprocal. So what I'm going to do is just change these over, and it'll be right back to where we started. In this first one, I need to rewrite the problem. This is the same thing as 2/3 times the reciprocal, 2 over 1. 4/3. Same thing on the next one. Keep the first fraction and then multiply by the reciprocal. Looks like these have some things in common, like 3 and 9 and 6 and 12. Multiplying across the top, I get negative 3 over 2. For the next example, you see something a little different. We need to multiply by the reciprocal of 2. The reciprocal of 2 is just 1 over 2. Now looking for numbers in common, 2 goes into 6 3 times. So I have 3/7. And finally, one with variables. Keep the first fraction, and then multiply by the reciprocal of the second. Some y's cancel. 5 goes into 10 twice, and 7 goes into 28 4 times. So altogether, I have 4x in the numerator and 2 in the denominator. But this isn't simplified. I missed something. Look back here. There was a 4 and a 2 together in the same fraction. What we can do is actually reduce that again, or, like I showed you before, we could go back and just reduce the final one. It's up to you. Here, 2 goes into 4 twice. So the completely simplified answer is 2x. You'll need to write all of your work in completely simplified and reduced answers.